Cluster analysis in R. Clustering. It is an unsupervised machine learning technique in which there is no defined function and no dependent variable defined. Clustering is a technique of data segmentation that partitions the data into several groups based on their similarities. And these smaller groups that are formed from the bigger data are known as clusters. For example, a marketing company can categorize their customers based on their economic background, age, and several other factors to sell their products in a better way. Some of the applications of cluster analysis can be used in marketing, wherein customers can be clustered as per potential buyers of the product. It can be used in retail to group the customers based on their performance, style, choice, and their preferences. It can be used in medical science to facilitate efficient diagnosis and treatment of their patients and discovery of new medicines. Sociology to divide people based on their demographic, lifestyle, and economic status, and any other factor that can be responsible for the making of clusters. So you can see an example here wherein there are students, their marks of physics and maths. So there is three different groups that has been formed based on the marks of the students. So in PQR, as you can see, there is a range of marks wherein there is similarity within the group similar to XYZ. There is also a similarity in the marks, and ABC you can see there is a similarity. So there are three groups formed. One is the ABC part, ABC students, then PQR, then there is PQR is this one, and this is the XYZ students. So cluster analysis tells the clusters should be homogeneous within and heterogeneous to other clusters, which means they should have similarities within the group, but there should be difference in comparison to the other group. There should be no dependent variable. There is no dependent variable means we are not predicting here anything, but we are grouping a data set into different clusters based upon a set or a function. That means based on similarities we are creating groups. We are not predicting any of our variable here. Then segmentation is based on the value of input variables and concept of similarity. So this is what we were talking about, that based on similarity concept, segmentation is done for the data set. Next, the types of clustering. So there are two types of clustering methods. One is hierarchical clustering and the second is k-means clustering. Hierarchical clustering is set of nested clusters. So there are many clusters and they are grouped together, they are nested together to form a bigger cluster. It is a good clustering technique for small data sets wherein the data is less than 100. Each pair of object is progressively nested into larger one and stops when one cluster remains. So what does it mean? It will start from the single pair of cluster like the bottom ones, then they will be nested together to join another cluster and going ahead making a large cluster wherein all the clusters will be joined with the bigger one. Then the running time is slower. So to create a hierarchical clustering, the time that is required is much more as compared to k-means. There is no parameter required for making clusters in hierarchical clustering. Then the graphical output of hierarchical clustering is known as dendrogram. So this type of graph which is created for hierarchical clustering, it is known as dendrogram. Then there is k-means clustering wherein the data is divided into m number of clusters. So if I am saying m number of clusters, so what and these m number of clusters are divided based upon a parameter that is k, which means number of clusters. And the running time of this type of clustering is faster than hierarchical one. The graphical output in this k-means clustering is in the form of clusters, as you can see in the picture also. Each one based upon their similarities, it is grouped together and forms a different cluster. Then there is hierarchical clustering. Let's understand hierarchical clustering. The function used in R is hclust, which is used to create a function wherein the model will be created for hierarchical clustering. It means grouping similar objects into groups called clusters. The data is required can be performed with either distance matrix or raw data. So we can perform hierarchical clustering in two ways, wherein either we can create a distance matrix or a whole raw data can be used to create a cluster. There are two types of hierarchical clustering that are agglomerative nesting and divisive hierarchical nesting. So what does they mean? Agglomerative means starting from bottom, it goes up. So joining the smaller ones, then creating the larger one. And divisive, the term says itself, it divides the cluster starting from the top one and going to the bottom one, creating smaller clusters. Then so this is what it says: agglomerative nesting is the bottom up clustering, and divisive hierarchical nesting is the top down manner clustering. This image shows the dendrogram which we discussed in earlier slide. So how does it shows? The dendrogram shows clusters like the first split here, as you can see, is this one. Here it is DE and FG. These are the base of clustering. Then this cluster is joined with another observation and creates a bigger cluster. And these two different clusters, they join together to create a bigger cluster. And once they are joined with the biggest cluster, which joins the whole of the clusters nested below them. We can always cut a line here, like we can split the dendrogram to that point where we can specify the number of clusters that we need. We will be discussing it in the coding part. Similarities between two clusters. So to know about the similarities between two clusters, there are different methods. First is minimum method, that is the single linkage algorithm. How does it moves? Finding the shortest distance between 2 points in each cluster. Suppose there are two clusters C1 and C2. So in a single linkage algorithm, the shortest distance will be calculated between each of the clusters, wherein you can see this is the point 1 and point 2. They have the shortest distance between the two clusters. Similarly, for the maximum, it is the complete linkage algorithm, which finds the longest distance between the points in each cluster. So in C1 and C2, you can see the farthest points has been joined, showing that the longest distance between the two cluster is this. So these methods, they help us find the distance and creating the clusters based upon the distance. Next is grouping group average, wherein the average linkage hierarchical clustering is done. The average distance between each point in one cluster to every point in other cluster is compared. So in C1 and C2, each of the point will be the distance with each of the point will be calculated from the each single point. So if this is a one point, if this is the point here, it will be compared to each of the point in the other cluster. Like a single point in C1 will be compared to each of the point in C2. Similarly, the second point will be compared to each of the point in C2. So this is how a distance matrix will be created. Then it is distance between centroids. To compute the centroids of two clusters C1 and C2 and take the similarity between two centroids as the similarity between two clusters. So in this two center points are calculated in both the clusters in order to find the distance between them. So they are the mean points or the centroids of each cluster. K-means clustering. The formula used in K-means clustering for R is K-means. Then what does K-means clustering means? Grouping similar data points together and discover underlying patterns. So k-mean clustering works on continuous variables. It defines a target number to be divided by which the clusters will be created. It is named as k, which refers to the number of centroids you need in the data set. It can be imaginary or real location of centroids. So we will understand in code part how can we create clusters using both of these type of techniques. Then the mean in the k-means refers to the averaging of the data, that is finding the centroids. We use elbow method to find the ideal number of clusters. So in order to get the optimal number of clusters to create the clusters, we will be using elbow method. There are two methods that can be used in elbow method to find the optimal number of clusters. So as you can see in the image also, if these are the two clusters based upon income and age, so these are the center points or the average of the data of that cluster. So this is how the clusters are created. If we wanted three clusters, the three centers are created and all the data nearest to that point will be grouped into each clusters. Distance measurement of clusters. Now this is important part because calculating distance of the clusters is important in order to get a good quality of output. So there are two kind of distance we can find out in R. One is Manhattan distance and the other one is Euclidean distance. So Manhattan distance captures the distance between 2 points by aggregating the pairwise absolute difference between each variable, and Euclidean distance captures the same by aggregating the squared differences in each variable. So what does it mean actually? So you can see there are two data points here, P1, P2, Q1 and Q2. So there are 2 points on x-axis and 2 points on y-axis. The distance between when you mark the points here, the distance between P and Q is this. So how to calculate this distance is the Pythagoras theorem, if we remember. So we will find out the Euclidean distance by squaring the difference between both of the points and adding the differences of square and taking the square root of that. You can see in the formula also. So it is the square root of Q1 minus P1. So this distance minus its square plus Q2 minus P2 square of it and taking the square root of the entire value. Then Manhattan distance, what does it do? It takes the absolute value of the difference between the points. It will add up the value of the distance here and here, and it will add up the value, and that will be the distance of P and Q. So this is how Manhattan distance and Euclidean distance are calculated. If 2 points are close on most variable but more discrepant on one of them, Euclidean distance will exaggerate the discrepancy. Manhattan distance will shrug it off. So what does it mean? If there are a large number of data, if we have large number of data set available, and we want to create clusters using the distances between each cluster. So in the Euclidean distance, it will exaggerate the discrepancy. What does it mean? If the 2 points are close on most variables, if suppose these are the 2 points and they are close to more variables available to us, then the clusters will not be formed correctly for the Manhattan distance because it shrugs off all the closeness of other variables. So it shrugs off being more influenced by the closeness of other variables. So if the distance is closer to one point, it will not divide the variables equally to all the clusters, but in Euclidean distance, because we are taking aggregation of the square differences of each variable, it will do more calculation and will divide the data set or variables more properly.